This is note 6.4 to 6.5a. It's an alternative to the 6.4 to 6.5a notes you may have in your OneNote. This is alternative. I just like this one a little bit better than what we've got there. The first part of this starts about properties and review. The next one is rectangles, and then we have rhombi, and then we have squares. So rhombi is just plural for rhombus. So I'm going to review with you just a little bit. If you've already got parallelograms pretty well down, then go ahead and switch to the other pages. So the first thing is we need to remember these properties. Opposite sides of a parallelogram are parallel. Oops. Well, so those are parallel, and then those are parallel. And that could be an arrow, it could be a triangle on there. Opposite sides are congruent. Opposite angles are congruent. Consecutive angles, meaning this angle and this angle, or that angle and this angle, or these two angles or these two angles, they add to be 180. And then diagonals bisect each other. So the reason why we go over these to review is because in the next shapes, all of these properties you're going to see are applying to all the other shapes that are coming up. So a parallelogram is kind of like the parent to the square and rectangle and rhombus. So if we want to find the length of CB, you have to think about the properties. So this is a parallelogram. Opposite sides are congruent to each other. These are describing the sides of the angles. So we know that AD has to equal BD. So the way you set up that equation is you get 4x plus 5 equals 7x minus 4. And you'll end up with x equal to 3. But you have to find CB, so don't forget to go back there. So CB, if you plug it in, you end up with 17. Because we did this to plug it in, CB equals 7 times 3 minus 4. Number 2, solve for x and a. So look and see what you've got. We've got two angles that are congruent to each other, so that should be an easy one. The measure of angle A equals the measure of angle C. So we're using that property that opposite angles are congruent to each other. So we know that 50 equals 2y, so we know that y equals 25. But then we have to find this one. Well, we know that consecutive angles are supplementary of each other, supplements, 180. So we know that the measure of angle A plus the measure of angle B equals 180. Plug in what we know, 50 plus 3x plus 10 equals 180. When you solve that, you get x equal to 40. Number 3. Now this one is slope. This is why I like this lesson, because they pull in the slope and the distance formula and midpoint formula for you to remember again. So we have to find the slope. So you need to remember the formula for slope is m equals y2 minus y1 over x2 minus x1. Okay, A is located at negative 3, 5. B is located at 7. So this is x1. I'm going to choose this one to be x1. This is y1. This is x2. This is a y2. So the slope of AB, if we look at this, the slope of AB should equal CD, because in a parallelogram, opposite sides are parallel to each other. So these two lines have to have slopes that are exactly the same steepness. So if I plug this in, let's see, the slope of AB equals 7 minus 5 over 6 minus negative 3, which equals 2/9. Well, we know the slope of CD is the same thing as the slope of AB. So the slope of CD also equals 2/9. And then this one, 2x plus 14 is part of a diagonal. CE is 6x plus 2. That's a diagonal. So what do we know about diagonals? Diagonals bisect. So we know that AE and EC are congruent to each other. So AE equals EC. So 2x plus 14 are the expressions that represent that. We end up with x equal to 3. But then it asks us to find AC. Well, AC is just going to be the sum of these two together. So if I find AE equals 2 times 3 plus 14, that equals 20. AE. And so then, since this is 20 and this is 20, then AC equals 40. Or CA. So that's properties of parallelograms. Now, all of these parallelograms properties also show up on rectangles. So if you look at this one, it says all 5 properties of the parallelograms, because parallelograms are rectangles, but what makes them different is that there are right angles in the corners. And then the diagonals, because of this, are congruent. So a parallelogram becomes a rectangle when it has right angles, and when the diagonals are congruent to each other. So if we call this A, B, C, and D, AC equals BD. Which is interesting because it also shows us that now I have this triangle congruent to that triangle, and this triangle congruent to that triangle, because the diagonals bisect each other. So we have some congruent triangles that show up by angle, side angle, side. We also have, if we look at it like this, if this is our rectangle, we also have 2 right triangles right here. So Pythagorean theorem, a squared plus b squared equals c squared, can be used to find any of those lengths and the diagonal relationship. All right, so let's go and solve some of these. So here are the example problems. We have to think about these properties. These are still parallelograms, but also, since they're rectangles, we also have 4 right angles and diagonals are congruent. So for this one, we solve for x and we solve for y. All the angles are 90 degrees, so that helps us with that 3x. So the measure of angle B equals 90 degrees. So that means 90 equals 3x. So x just equals 30 degrees. Then we do the same thing with the y's, but it's not an angle, it's a side. And what do we know about opposite sides? Well, they're congruent to each other. So we know that CD, and that is because this is also a parallelogram, equals AB. So 8y minus 6 equals 4y plus 2. Solve that and you get y equal to 2. Next one, BE. BE is a diagonal. And what do we know about diagonals in a parallelogram and a rectangle? Well, we know that the diagonals are split into 2 equal pieces. So that's easy to think about because it's a parallelogram. And then we also know that the diagonals are congruent to each other because it's a rectangle. So we can say that AC will equal BD. So as soon as we find BD, we've got AC. So for BD, we've got BE, one piece, equals ED, the other piece, because diagonals split. 7x plus 5 equals 3x plus 21. So x equals 4. So if I want to find BD, BD is just going to be 2 of the BEs. So that equals 2 times 7 times 4 plus 5, which equals 33. So BD, is 66. So now we know that AC equals 66 because the diagonals are congruent. The length. Length has to do with the distance formula. or Pythagorean theorem. They're kind of about the same thing. So we want to find the length of BC, and BC is right here. It's not even related to that 6 and A, or is it? We know that the diagonals are congruent, so we're going to use that property. Diagonals are congruent. So if I just look at triangle ADB, I know there's a 90-degree angle right there. I know this is 6. I know this is 8. So if I use Pythagorean theorem on this, I'm going to be able to figure out what AD is. I'm going to put an X right there. Because once I find AD, that's equal to BC. So this is the hypotenuse. This is a leg. This is a leg. Leg squared, or 6 squared, plus the other leg squared, or 8 squared, equals the hypotenuse squared. This will be 100 equals x squared. So I know that x equals 10. Well, that's just be D, or AD. But AD equals BC. So now I know BC equals 10. And then this one has to do with slope. B is located at negative 6, 3. And C is located at negative 1, 6. So we have to find the slope of CD. We know this is 90 degrees. We know that this slope, or this line is perpendicular to that one. So if I have the slope, say it's A over B or whatever it is, the slope of the perpendicular line is going to be the negative reciprocal. So whatever I get for the slope of BC, so the slope of BC equals 1 over, is going to be 1 over the slope of CD. In other words, we're going to find the reciprocal of whatever the slope is for BC. Okay, so I can write it this way. The slope of CD equals negative, the negative reciprocal of the slope of BC. So we need to find the slope of BC. So the slope of BC equals y2, which is 6, minus y1, which is 3, all over x2. So here's my x2. Here's my y2. So x2 is negative 1 minus negative 6, which equals 3 over 5. So if I want to find the slope of CD, the slope of CD is just going to be the negative reciprocal. So since the other one is positive, we just put a negative there and we flip it. There's the slope of CD. Because those two lines are perpendicular. So for rectangles, all 5 properties of a parallelogram and for right angles, and we have diagonals congruent, and we can use Pythagorean theorem on this one. Rhombi. Rhombi is just perpendicular for a rhombus. So again, it's all the properties of the parallelograms, but there's also 4 congruent sides. Also, when those diagonals cross, they're perpendicular to each other. And also the diagonals bisect opposite angles. So those are congruent, but they split the 2 congruent angles. So those are congruent, and those are congruent. So let's look at this one. Find the length of DC. DC is right here. Well, it's the same thing as all of those. So we know the sides are all the same in a rhombus. So we know that AB equals BC, and that equals CD. So if I use this relationship and plug in my expressions, I end up with x equaling 5. So if I want to find AB equals 5 times 5 minus 11. So AB is going to equal 14. Well, AB equals CD. So that would be our CD. Okay, this one. EAB is 5x minus 1. So EAB is 5x minus 1. The measure of angle ABE is 8x. And then we also know that this is a right angle right there because the diagonals bisect. And what else do we know? What do we know about the sum of the angles in a triangle, a right triangle? The sum of all of these angles is 180 degrees for a triangle. But if I have an angle here and an angle here, angle A's measure plus angle B's measure has to equal 90 degrees. So the sum of the acute angles equals 90 degrees. So I can really take the measure of angle EAB and add that to the measure of angle EBA, and those will equal 90 degrees. So this angle plus this angle equals 90 degrees. So I'll plug in my expressions. 5x minus 1 equals 8x, and that equals 90 degrees. You can do it with the sum of the angles equals 180, and that works just fine. But this way, you save yourself a step. That's supposed to be plus. Okay, so when I solve that one, I get x equal to 7. But it says to find the measure of angle ABE. So the measure of angle ABE is going to be 8 times x, which equals 8 times 7. So that equals 56 degrees. 11. The measure of angle DCB equals 120 degrees. 120 degrees. The measure of angle ABD is what we're trying to find. So we have to think about this. What do we know about angles? The angles are bisected. We also know, because it's also a parallelogram, that consecutive angles add to be 180. So what we're going to do with this is let's figure out this whole entire angle right here. So that whole entire angle, we also know, since that's supplementary, we know that this angle is 60 degrees. Well, the diagonal splits that angle in half. So now we know that each of these are 30 degrees and 30 degrees. And we have to find the measure of angle ABD. We got it. The measure of angle ABD equals 30 degrees. So these are just kind of like a puzzle. You figure out, what do I know and what do I need to know and what properties will help me get there. And then it works out all right. Okay, this one, the diagonal, the length of CE, since all the sides are the same, I know this is 15, and I know this is 15, and I know this is 15. I also know that diagonals cross at 90 degrees. So it creates 4 right triangles. So this right here is the leg. I'm going to call this X. This is a leg. And this is 15. This is the hypotenuse. So again, we're using Pythagorean theorem on this. X squared plus 9 squared equals 15 squared. Solve that, and we get x equals 12. Take that x equals 12, and we know that that would be CE. Well, we know that CE then, CE equals 12. Okay, so we've got parallelograms. Those properties apply to rectangles. The difference between parallelograms and right angles and rectangles is that there's 90 degrees in each corner and the diagonals are congruent to each other. A rhombus, same properties of a parallelogram. The difference here is that there are four congruent sides, diagonals are perpendicular, diagonals bisect opposite angles. And then we have squares. It's all 9 properties of parallelograms, rectangles, and rhombi. So basically we have quadrilaterals that if we break it down, they turn into parallelograms. If we make the sides parallelograms. The parallelogram could be a rectangle or a rhombus, depending on which one these are, which properties are given to us. Then a square. A square is a rhombus because all the sides are the same. Diagonals bisect at 90 degrees, and the diagonals also bisect the angles. It could be a rectangle because the sides are 90 degrees, the diagonals are congruent to each other. So the square is everything. So here we go. C is located at -3, -4. D is located at 1, 2. And we want to find DA. Well, DA is the same as all of those. For this one, we'll use the distance formula. So whenever we find DC, we've got DA. So DA, or DC, here's the distance formula, the square root of the difference of the x's plus the difference of the y's. Oops, 1 squared. Let me fix that. Put a 2. There we go. 2 minus y, 1. And then you take the square root of it. So DC equals, now here's your x. Here's my x2. And here's my x1. So it's going to be the square root. Notice those don't come from the same coordinate points. So this is going to be -3 minus 1 squared. So that equals -4 squared, which equals 16. Okay, and then we're going to do y2 minus y1. So y2 is right here, and y1 is right there. So this will be -4 minus 2 squared. So that equals the square of -6 squared. Notice that these never, when I square them, they never turn out negative. 36. So this is DC. So DC equals the square root of 52. Well, DC and DA are congruent to each other. So that's that. And the last one, we got to use the midpoint formula. So the midpoint formula is like this. Maybe that silly G. XM YM equals x1 plus x2 over 2, y1 plus y2 over 2. So A is located at 210. C is located at 5, 7. And we want to know the coordinates of that point right there in the middle. So we're going to do the midpoint. So this will be 2 plus 5 over 2 and 10 plus 7 over 2. So that point E is at 3.5, 8.5. All right, that's it. There's lots of properties that we had to go over, but hopefully you'll understand this a little better. And you can do the worksheet that goes with this just fine. If you have any questions, let me know.